I've populated parts of the PCBs and we've got it in the case here. The display is just wedged in with foam at the moment and that's a bit tight, so the case isn't fitting together too well, but it does actually fit together. Got a programming cable hanging out there and it runs off a PP3. So if I attach that and turn it on, the power circuit for the on buttons there, you can see the display initialises and lights up with some garbage. I've got timing problems with the OLED I2C, I think. That does actually come up with the demo code, but not always. Not really sure what's going on at the moment. I'll pull that out and take them apart. You see the Wi-Fi module there. Data packs are plugged in here. This is the power PCB for a better name. Haven't actually populated much on there because that's not necessary to run the front half. It's just got the keyboard here. Layout seems fine on that. There's an OLED display there, temporarily held in. I'm going to have to 3D print some sort of frame or something to attach it to the PCB probably. And I've got the battery connector here for a PP3 which runs everything. 12 volt step up converter there to get the 12 volts that's needed for the OLED display. I've jury-rigged or jumpered the transistor that turns the display on. I've got that as a possible low power feature. Down here we've got some shift registers. There's 2 output registers providing 8 extra bits of output and 8 bits of input as well. That's for the keyboard scanning. So it's similar sort of circuit to the actual original Organiser 2 but slightly different. These are really just GPIO expanders for the keyboard and other functions. So the reset for the OLED display is coming off one of these. So this is working. The Pico obviously there. I've had to cut a bit of the case away to get the USB connector to fit. I think the way to go is probably just to remove that. Because you've got Wi-Fi you shouldn't really need the USB. It's not used for power. I mean it would work for communications and power, and it does if you take it out of the case, because you can get to the connector then, but obviously then you haven't got the keyboard and the display's sort of flapping around. So at the moment I'm running it off the PP3, but I'm going to have a look at running it off something else because that's getting a bit tedious. Yeah, so quite a bit of code now and a little bit more populating of stuff. This up here is the real-time clock. Unfortunately I don't have that entire chip in the particular footprint I put down, so I can't actually populate that at the moment. I haven't bothered doing any more of this. The top slot I think fits. These connectors for the data pack and top slot need spacing off. They're not actually the same as the ones that the original Organiser had. The connection between the 2 boards should be alright as well. It looks physically to be closer than the original Organiser, and I did manage to retrofit that to the original even though they're staggered a bit, so that should be okay as well. So it's really just a matter of finding out why the I2C to the display isn't particularly reliable. We're not getting the demo code all the time, but everything looks okay-ish at the moment. I mean there's obvious problems. I've missed some holes out. The hole here for this screw isn't there, so it's going to be a bit tricky putting that screw in, and a few other little bits and bobs, but nothing major, and they do fit in the case quite well. So onwards as ever. After a bit of investigation, it turns out the I2C code, the by display demo code, had a little bit of a timing issue I think, and that meant that it would work okay if you had good signals and weren't running sort of less than optimal signals on the I2C bus. So I've adjusted that and now I'm getting the demo display there. I put some delays in. The whole thing was based off one sort of delay routine and I've separated that out, so now it's 1 second I think it is for each of the displays, and that's running pretty nicely. This is currently running off a USB, so I've got the battery with 5 volts going in, which is quite a low voltage, but everything works with that, and the 12 volts is fine. There's a little bit of whistling going on. I get a lot of whistling with that 12 volt circuit. I've used it before, and where it's white there's a little bit of noise on the display. I might put some more filtering on and investigate that, but at the moment that's not really a priority. So that's running with a pretty long delay between the actual frames. I'll change the delay and make it as fast as I sort of reasonably want to go, and you'll see the refresh rate of the display is pretty high. So this is the same code, but I've changed the delay from 1 second between the frames to 1 millisecond, and you can see it's got a pretty good update rate there, and it's running at, let me do a measurement here, it's running at, on the I2C bus, if I can get my scope to measure it, quite unhappy at that speed, it's running at about 400 kilohertz it's saying on the clock, so it's running pretty fast. It's probably a little bit faster than I'd want to run it. I'd probably want to run it at 100, but I think that update rate will be fine. If I change change it back, let's change it back to 1 second and rebuild that. And program it. I'm using Eclipse here. Using the standard Raspberry Pi Pico SDK and programming setup. So if we go back to 1 second, that's stopped. Here we go. So that's a pretty instant update for the entire screen there. And this is bit bashed out of a GPIO. Well, 2 GPIOs for the I2C bus. I'm not using the Pico's PIOs or the I2C peripheral. I'm just bashing it out of the GPIOs with quite a lot of delays actually as well. It's a pretty fast processor, the RP2040. So I'm quite happy with that. I haven't seen any trouble with it. Obviously the display's upside down, but that's just the mechanics of how I fitted it in the case. So next step's probably to have a look at the keyboard scanning and get the emulator in there. And then the front half here, this will be a sort of emulation of an organiser with no slots, and then move on to the slots which are on the other PCB, which I haven't really done a lot with, not electrically anyway. I wanted to get this working because obviously if I can get the emulator running on here, that's sort of a major part of this project.